Welcome back. The last video that you had was proving that two triangles were similar. Now, to continue with this similarity topic, you're going to apply the basic proportionality theorem and the midline theorem in solving exercises. Okay, let's start with the basic proportionality theorem. What does this theorem say? It says here, if a line parallel to one side of a triangle intersects the other two sides in distinct points, then it cuts off segments which are proportional to these sides. In other words, we are given that DE here is parallel to AC. Then the conclusion is that DE here will cut proportional segments. So in here we have side BA is to side BD as side BC is to side BE. Also, we can say AD is to BD as what? CE is to EB. In fact, we can also say here that AC is to DE. Okay, let's try explaining that in another form. Let's say here we have uh, triangle ABC. Triangle ABC here, A, B, C. And then if I have this segment or the line containing this segment drawn parallel to the third side here, then what do we have? Instead of mentioning the length of segments here, I can say, let's say this is A, this is B, this is X, this is Y, and then this is C, and this is D. All of these numbers are real numbers, okay? A would now represent the length BD, and B will represent the length DA, etc. X will represent the length BE, and then Y will represent the length EC. Now, the basic proportionality theorem here just tells us that we have the following ratios, okay? I can say here, I can say A is to B, okay, equals X is to Y. Okay, that's what it's trying to say. Now, note that we can invert this and say B is to A equals Y is to X. Now, these are segments that were cut. Okay? Now, we know that if this is parallel to this, what happens is this angle here will be congruent to this. They are corresponding angles of parallel lines. And this angle will be congruent to itself. And this angle here will be congruent to this angle there. Hence, we have triangle DBE is similar to triangle ABC. Okay, I will separate that. Triangle DBE is similar to triangle, the big triangle ABC by AAA similarity theorem. Therefore, I can have this side here proportional to that, this side here proportional to that, this side here proportional to that. In other words, I can have here DB is to AB as BE is to BC as DE is to AC. Okay? Now, these are sides. These are sides. Here, these are segments. Okay? These are segments. So, I cannot equate this one here, I cannot equate it to the sides here, CD. Okay? They are not equal. Okay? They're not equal because these are segment, 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 segment. Okay. However, I can express the ratios in terms of A, B, X, and Y in this manner. A is to the whole side. What's the whole side? A plus B. That's actually what? DB is to BA. BA is actually what? A plus B. And I can have what? The side x to the whole side, which is x plus y. And this side here, C is to D. Ganun lang. Okay? And they're proportional. And this is equal to a certain K. Okay, so that's what the basic proportionality theorem is trying to tell us. These segments here are cut off proportionately and their length will be proportional. So A is to B, X is to Y. And if you take the two triangles that are similar, then you can state the proportionality in terms of the sides. So A is to the whole A plus B, X is to the whole X plus Y, and then I can say D is to C is to D. Okay. Now, the midline theorem is a special case of the basic proportionality theorem where the third side here intersected the two sides in the midpoints of the two sides. So this is congruent to this and this is congruent to that. That's a very special case. And if that happens, then this length here, C, is actually 2 times this length. So B here is equal to 2C. That's exactly only what the midline theorem is trying to say. Okay? If B and E are the midpoints, then the length here, C, is half of this one, D here. Okay? So let's get some applications to these theorems. Okay, apply the basic proportionality theorem to solve the following numbers. Okay, here we have DE is parallel to AB. So DE here, that's the requirement of the basic proportionality theorem. That this line passing through the other two sides here uh, and parallel to the third side will cut off proportional segments. So we can now say that DC is to DA, CE is to EB. What else? DC is to CA and CE is to CB and DE is to AB. Okay, that's what the basic proportionality theorem is trying to tell us. So if you are given the whole length here to be a 9, AC is a 9, and CD is 3, BC, the whole BC here is 18, and you're asked to find CE, that is, let's say, X. Okay? From the basic proportionality theorem, we have two congruent, similar triangles. Triangle CDE is similar to triangle CAB. Okay? Now we can have this ratio, that side from the small triangle over the side from the big triangle equals the side from the small triangle over the side of the big triangle. Okay? And we can readily find CE, which is X. I can cancel 3 and 9 or I can cancel 9 and 18. It doesn't matter, but this can be canceled to this, and this will be what? 2. Now I can have that cross multiplied, and PE will give me X equals 6. Okay? So that's how easy it is to apply the basic proportionality theorem. You can do the same thing here. Okay? Now, I want us to slide through uh, similar here. Find from the given figure QR is parallel to MP, so you can apply the basic proportionality theorem. And it says here, find all the values of Mn. Okay, before we can find the values of Mn, we have to find the value of X. Okay, so the quickest ratio that we can produce here will be what? The segments. 3x minus 6 is 2, 2x plus 7 as what? x plus 3 is to 2x. Okay? This is a rational equation, and you can solve by cross multiplication. I can have 2x plus 7 times x plus 3 equals 2x times 3x minus 6. So this will now give me 2x squared plus. The middle term is 7 plus 6 is 13x. 7 times 3 is 21. This is 6x squared minus what? 12x. I can transfer everything to the right hand side, so this will become a positive coefficient. 6 and 2 will give me a 4. The 13 goes here, it becomes negative 13. I will get a negative 25x. And I have a negative 21. Okay? So, is this factorable? The middle term is uh, negative 25. Okay, so let's see if we can factor this. The factors of 21 are 7 and 3. I can have here probably 7, and I can have a 3 here. I can have 4 here, or minus, so this is minus. And this is x, 1x. This is 4x. This should be a plus 3. Okay, 4x times x will be 4x squared. 3 times minus 7 is minus 21. The middle term is plus 3x, and negative 28 will give you negative 25. So there are two factors now here. This one will give me x equals negative 3 over 4, whereas this one gives me x equals 7. Okay, now x equals 7. I cannot use this because it's a negative. Uh, can that be negative 3 over 4? This becomes negative, so it cannot be a side. Okay, so we can only have the 7. So we get find all values of mn. Okay, mn. Let's have x equals 7 first. If x is 7, 3 times 7 is 21, minus 6. 21, 11, 65, 15. So this is 15. What about this? 2 times 7 is 14 plus 7, 21. So mn will now be 15 plus 21, or that's 36. That's one value. Okay, let's see if this one will not give us a negative value. X equals negative 3 over 4. X equals negative 3 over 4. I will erase the board. If x equals negative 3 over 4, what happens to this? This becomes negative. Okay? So, we only had one value for mn. Okay? Now, what about the midline theorem? Okay. I'll probably just say, if we have the midline theorem, uh, if this is cut at the midpoints, okay, cut at the midpoints, this one is congruent to this is congruent to this. If this is 6, then this must be 12. That's just it, the midline theorem. Okay? So you can do the other exercises.